Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks. Hello and welcome. This is Michael Annis, and you're listening to episode 142 of the Space Rocket History Podcast. And now, Venera 4. Venera is a Russian word meaning Venus. It is also the name given to a series of unmanned Soviet probes that were sent to investigate the planet Venus. The first 3 probes had originally been designed to explore Mars, but they were repurposed as Venera probes to visit Venus. The first probe, Venera 1, was launched on February 12, 1961, but radio contact was lost before it flew by Venus, thus the probe was a failure. Venera 2 was launched November 12, 1965, and in February of 1966, the probe managed to fly by Venus at a distance of 24,000 kilometers, but its instruments failed before it could send the data back to Earth. The probe eventually began orbiting the Sun, another failure. Venera 3 was launched on November 16, 1965. The flight to Venus was mostly uneventful, but communications was lost with the spacecraft just before the entry body reached the Venusian atmosphere. We do know that the probe impacted on Venus on March 1, 1966, which made it the first spacecraft to impact on the surface of another planet. And then there was Venera 4, also designated 4V-1 number 310. The 4th probe sent to Venus by the Soviets. Its goal was to soft land on Venus and return data about the planet and its atmosphere. Now I'm going to describe Venera 4. Keep in mind, a good description does not require a picture. You're going to need a picture with this description. The main hub of Venera 4 stood 3.5 meters high. Its solar panels spanned 4 meters and had an area of 2.5 square meters. The hub included a 2-meter-long magnetometer, an ion detector, a cosmic ray detector, and an ultraviolet spectrometer capable of detecting hydrogen and oxygen gases. The devices were intended to operate until entry into the Venusian atmosphere. At that point, the station was designed to release the probe capsule and disintegrate. The rear part of the hub contained a liquid fuel thruster capable of correcting the flight course. The flight program was planned to include 2 significant course corrections, for which purpose the station could receive and execute up to 127 different commands sent from the Earth. The front part of the hub contained a nearly spherical landing capsule, 1 meter in diameter and weighing 383 kilograms. Compared to the previous 3 failed Venera probes, the capsule contained an improved heat shield which could withstand temperatures up to 11,000 degrees C. Instead of the previously liquid-based cooling design, a simpler and more reliable gas system was installed. The durability of the capsule was checked by exposing it to high temperatures, pressures, and accelerations using 3 unique testing installations. The heat resistance was checked in a high-temperature vacuum system emulating the upper layers of the Venusian atmosphere. The capsule was also pressurized up to 25 atmospheres. The surface pressure on Venus was unknown at that time. Estimates ranged from a few to hundreds of atmospheres. Finally, it was subjected to accelerations up to 450 G in a centrifuge. The centrifuge test caused cracking of the electronic components and cable brackets, which were all replaced shortly before launch. The timing for the launch was rather tight, so as not to miss the launch window. As an example on how little was known about the surface of Venus, the capsule was designed to float in case of a water landing. Considering the possibility of such a landing, its designers made the lock of the capsule using sugar. It was meant to dissolve in liquid water, releasing the transmitter antennas. The capsule contained a newly developed vibration dampening system, and its parachute could resist temperatures of up to 450 degrees C. The capsule contained an altimeter, thermal control, a parachute, and equipment for making atmospheric measurements. The atmospheric measurement equipment included a thermometer, barometer, hydrometer, altimeter, and a set of gas analysis instruments. The data was sent by two transmitters at a frequency of 922 megahertz and a rate of 1 bit per second. The measurements were sent every 48 seconds. The transmitters were activated by the parachute deployment as soon as the outside pressure reached 0.6 standard atmospheres, which was thought to occur at an altitude of about 26 kilometers above the surface. The signals were received by several stations, including the Jodrell Bank Observatory. The capsule was equipped with a rechargeable battery with a capacity sufficient for 100 meters of powering the measurement and transmitter systems. To avoid becoming discharged during the flight to Venus, the battery was kept charged using the solar panels of the hub. Before the launch, the entire Venera 4 station was sterilized to prevent possible biological contamination of Venus. Two nominally identical 4V1 probes were launched in June 1967. The first probe, Venera 4, was launched on June 12th, and the second probe, Cosmos 167, was launched on June 17th, but it failed to depart from low Earth orbit. The carrier rocket for Venera 4 was a Molniya M. You may recall the Molniya M carrier rocket was a derivative of the famous R7, model number 8K78M. The Molniya M was 43.4 meters high and almost 3 meters in diameter. It weighed 305,000 kilograms and had 3 stages fueled by liquid oxygen and kerosene. Venera 4 was launched from the Baikonur Cosmodrome. During flight, a course correction was performed on June 29th when it was 12 million kilometers away from Earth. Otherwise, the probe would have missed Venus. Although 2 such corrections had been planned, the first one was accurate enough and therefore the second correction was canceled. On October 18, 1967, the spacecraft entered the Venusian atmosphere. Now we have an eyewitness account of Venera 4's encounter with Venus from Mission Control at tracking station number 16. These are the words of Boris Chertok. Quote, "We got to Yevpatoria by dinner time. The main contingent of Venusians had already gone to bed. Communication sessions with Venera 4 began at 4 a.m. The flight was in its 128th day. All along the flight route, communications had been quite satisfactory. The parabolic antenna developed by our antenna experts was sending information back to Earth that usually resulted in the report, "Signal good, reception stable." 8 rigidly connected 16-meter ADU 1000 parabolic antennas tracking Earth's rotation were reliably tracking the station's approach to the planet. It seemed that the nearby and mysterious planet was resorting to tricks to hide the secrets kept beneath its cover of clouds. As the probe drew near, Venus's gravitational field increased its speed. The Doppler effect altered the wavelength of the signals received on Earth. The radio operators needed to be particularly vigilant so that the information sent from the station consistently landed in the narrow throat of the ground-based receivers. After breakfast at 5:30 a.m., we were already in the main hall. The planetary approach communication session via the onboard omnidirectional antenna began at 5:36. Commands had been issued to orient the onboard parabolic antenna toward Earth. Boguslavsky, the deputy chief designer of the Ryazanski Design Bureau, was beaming. "The signal-to-noise ratio is 1,000, 40,000 kilometers to Venus." As the spacecraft approached the planet, its speed increased. We perceived this by sound, by the increased frequency of the clicks in the speaker to which the audio signal was fed from the space speedometer. In honor of the occasion, we also set up a concise running commentary. 7 hours, 50 minutes Moscow time, 20,000 kilometers to Venus, reception stable, ratio 1400, onboard voltage 14.5. The calculated time for the separation of the bus and descent module was announced as 7:38 a.m. When separation occurred, the signal was supposed to disappear. The parabolic antenna would turn away from the Earth. After comparing the ballistics expert's prognosis with the change in Doppler frequency, Boguslavsky announced, "Arriving on Venus is going to be 10 minutes later than the ballistics expert's predictions." We made a correction. At 7:38 a.m. came the report. "Separation command. Loss of signal. We have separation." Now the bus would disintegrate and burn up in the atmosphere of Venus, and we would be on tenterhooks awaiting the appearance of a weak signal from the small sphere of the descent module covered with a thin layer of durable thermal shielding. It would enter Venus's cloud cover at a velocity in excess of 11 kilometers per second. According to the calculations, the descent module would decelerate to a velocity of 300 meters per second. If the little sphere remained intact, then the jettisoning of the hatch that pulls the parachute behind it would be crucial. If the parachute held up even somewhat and did not burn up in the hellish atmosphere, we would obtain invaluable information. Now, Babakin, the chief designer at the Lavochkin Design Bureau, called for silence and patience. He advised us that the temperature, pressure, and altitude would be reported virtually in real time by a well-trained group of telemetry operators. At 7 hours 44 minutes, shouts of elation were heard. "We have a signal. We're receiving from the descent module. We have telemetry." Reports came in one after the other. 7 hours 46 minutes, altimeter reading 28 kilometers, pressure 960 millimeters, temperature 78 degrees. Pressure is increasing rapidly. 8 hours, pressure 1400 millimeters, temperature 114 degrees. 8 hours 12 minutes, pressure 4.7 atmospheres, temperature 146 degrees. Temperature inside descent module 14 degrees. The radio altimeter has stopped giving readings. Someone noted over the public address system that it's hard to believe the altimeter now. It's out of kilter. Quiet. We'll sort it out later. Because of the loud running commentary that was interrupting the information being sent from Venus atmosphere in real time, all of us there in the tracking station number 16 operation rooms felt a rare feeling of involvement in this great discovery. Tomorrow, no, even today, the whole world would learn about the discovery of this mystery. But we, the ones who had made this discovery, would remain to the world a classified state secret. 8 hours, 18 minutes, temperature 167 degrees, pressure 5.6 atmospheres. 8 hours, 32 minutes, pressure 8 atmospheres, temperature 201 degrees. Temperature in the descent module is rapidly rising. It's now more than 20 degrees. 8 hours, 53 minutes. One pressure sensor went off the scale at 9.3 atmospheres. Temperature 250 degrees. Keldysh interrupted and said in surprise, "Our pathologist certainly didn't anticipate that the pressure could be that high. Now we won't find out the actual reading on the surface. We should have had another sensor with a greater range." I felt that not only I, but all of us had been caught up in the ineffable exhilaration of this discovery. The PA announced, 9 hours, 14 minutes, 9 seconds, loss of signal. Now the temperature is more than 280 degrees. In the breathless silence of anticipation, Babbicon could stand it no longer, and, violating established procedure, he declared, "Now it is clear that these flights have not been in vain. No one is going to start planning piloted landing expeditions to Venus." At 9:30, once again a shout rang out. "We have a signal. It's clean. No telemetry. No noise. We lost the signal." With that, history's first transmission from Venus ended. What the actual atmospheric pressure reading was at the surface, we simply didn't find out at that time. According to calculations, the descent module was supposed to have been crushed by external pressure. Then one of the scientists ran over to us from the telemetry operators and, gasping with joy, reported, "The primary atmosphere component is CO2. Oxygen makes up 1%. No traces of water, no nitrogen." Our tension was transformed into elation. We began embracing one another, exchanging congratulations. There were orders to accurately process the telemetry, prepare a good meal, and report to Moscow. Now, each of us was faced with so much work and so many headaches, but for those few minutes, everyone was smiling and walking on air. The restraint ingrained in us by our previous failures prevented us from expressing our feelings of personal and collective happiness in any other way. We felt like jumping for joy and roaring with laughter, but in our somber condition this was impossible, for each of the participants directly involved with the creation of the Venus interplanetary vehicles or their flight control, this was perhaps one of the happiest days since the flight of the first Sputnik. And on this day, during the descent module's 1 hour of descent on its parachute, we learned more about the secrets hidden under Venus's clouds than science had discovered during preceding centuries. Fate had rewarded all of us who had gathered that day at Tracking Station 16 with a generous gift for many years of hard work. The happiness of a scientific discovery is never complete. There and then, having just regained our composure, we began to bemoan the fact that evidently the descent module had not reached the surface and had been crushed by external pressure. None of the planetologists had expected that it would be greater than 5 atmospheres. It turned out to be greater than 9 atmospheres. But how many atmospheres had it really been? It was maddening that the pressure sensors had reached their limit, that the radio altimeter had failed, and that the chemical makeup of the clouds was still unknown. We had blazed the first trail. The descent module's hour-and-a-half stay in Venus's atmosphere had shown that a piloted landing expedition on the surface of Earth's closest neighbor in the solar system was a thing of the very distant future, significantly more distant than a landing on Mars. After a thorough processing of all the materials, it was proven that Venera 4 descent module made it to around 25 kilometers from the surface. End quote. Now, a few facts about the flight that Chertok did not mention. During entry into the Venusian atmosphere, the heat shield temperature rose to 11,000 degrees C, and at one point, the cabin deceleration reached 300 Gs. The descent lasted 93 minutes. The capsule deployed its parachute at an altitude of about 52 kilometers and started sending data on pressure, temperature, and gas composition back to Earth. The temperature control kept the inside of the capsule at -8 degrees C. The temperature at 52 kilometers was recorded as 33 degrees C, and the pressure as less than 1 standard atmosphere. At the end of the 26-kilometer descent, the temperature reached 262 degrees C, and pressure increased to 22 standard atmospheres, and the signal transmission terminated. The atmospheric composition was measured as 90 to 93% carbon dioxide, 0.4 to 0.8% oxygen, 7% nitrogen, and 0.1 to 1.6% water vapor. Malfunction of the altimeter resulted in the value of initial altitude being transmitted as 26 kilometers. Therefore, some Earth observers interpreted the descent as having continued to the surface of Venus, which was quickly dismissed as inconsistent with the other data. In particular, the pressure readings by the capsule were much too low for the Venusian surface. In conclusion, for the first time, in-place analysis of the atmosphere of another planet was performed and the data sent back to Earth. The analysis included chemical composition, temperature, and pressure. The measured ratio of carbon dioxide to nitrogen of about 13 corrected the previous estimates so much that some scientists contested the observations. The main probe detected no radiation belts. Relative to Earth, the measured magnetic field was 3,000 times weaker, and the hydrogen corona was 1,000 times less dense. No atomic oxygen was detected. All the data suggested that water, if present, had leaked from the planet long before. This conclusion was unexpected considering the thick Venusian clouds. Because of the negligible humidity, the sugar lock system employed on Venera 4 in case of a water landing was abandoned in subsequent Venus probes. Venera 4 was considered to be a huge success, especially given the previous failures of the first 3 Venus probes. Here's how the event was reported on the news.
Actually, great excitement throughout the entire Soviet Union when the nation's greatest space achievement was announced. A soft landing on Venus had been accomplished, and the equipment that was Earth's first surface link with a mysterious planet was working well. These pictures have been released to Pathé News by the Russian authorities and show their scientists making final adjustments and tests to the actual equipment which successfully covered the multi-million miles to the distant planet. Here, Russian space technicians submitted the vehicle to rigorous tests to simulate blast-off and landing. As the day of launching neared, the scientists stepped up their program in final preparation for the major assault on the shrouded planet. This is an animated reconstruction of how the Russian Venus probe looked in deep space. On Earth, listening posts, including Jodrell Bank, kept in constant touch. It was an achievement of space technology which rightly earned international acclaim for Russia and opened new space frontiers.
Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.